Programming is a skill that requires both knowledge and practice. One of the best ways to develop your coding skills is by solving classical programming problems. These problems are nice challenges that have been used for a long time to develop programming skills. These cover a wide range of topics, from basic programming concepts to complex algorithms and data structures. Today, we'll try to find the sum of even Fibonacci numbers up to a certain limit, let us say, n. Fibonacci is a fascinating sequence of numbers that have captured the attention of mathematicians for long. They are named after the Italian mathematician Leonardo Fibonacci, who introduced these in his book Liber Abaci in 1202. The sequence starts with 0 and 1, and each subsequent number is the sum of the two preceding ones, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Some people prefer starting the series with 1 instead of 0 as they believe Fibonacci series exists in the nature and there is nothing in nature that is 0. We'll look at different approaches to find the sum of even Fibonacci numbers. I will start with the generation of Fibonacci numbers and then move on to sum the series. There will be timestamps in the video and you may jump around. I would recommend you to watch the whole video as you may learn few tricks worth your while. Let us get started. I am going to use C# language to write these programs. You may use any language that you are comfortable with. This series is more about problem-solving approach and algorithms. Of course, I will share few things particular to C# language that may help people learning C# language. I am using Visual Studio. You may download Visual Studio Community Edition that has all the capabilities. I am using a simple console type of project. While creating the new project, just choose C# language and project type as console. I will copy-paste some of the code to not make the video very long. I am going to start by writing a method to generate Fibonacci numbers. I am not in favor of using underscores in the method names, but I am deliberately using it here. I am going to write many methods and I want you to be able to differentiate among these methods using these numbers. As a beginner, we may think of the next term f4 as sum of f2 and f3 and so on. f5 will be equal to sum of f3 and f4. But this creates a problem that for each Fibonacci term, we will have to use one variable. This approach is not scalable and possible as we don't know how many terms we are going to generate. So, how do we solve this problem? This brings us to the use of these classical problems to learn programming. These problems teach us small techniques that are useful later in writing complex programs. I want you to focus on the fact that the purpose of the variable f1 is over at this moment as we have already displayed its value. We don't need f1 anymore. Therefore, we can now use f1 to hold the value of f2. Now, the role of f2 is over and we can use f2 to hold the value of f3. We can now calculate f3 again as sum of f1 and f2. We can now keep this doing repeatedly as this is a repeatable pattern now. When we display f1 now, we are effectively displaying the second term of the series. When we repeat this pattern again, it will be the third term and so on. With this knowledge, let us rewrite this method. Our method can look something like this. The most important point to notice is how we are using the same set of variable to hold the next generation of values. We are generating 10 terms of the series but change this number to anything else and the method will generate the terms accordingly. Now, we can make a call to this method. This shall display the first 10 terms of the Fibonacci series. This shall display the terms starting from 1 up to 55. You may change the first term to 0 and the series will start from 0 and the last term will be 34. I leave it to your discretion if you want to display from 0 or from 1. Now, we know how to generate Fibonacci numbers. This is not the only approach but there are other approaches as well. One of the concept that we can touch upon at this moment is that if a function can be written in its own term, like we can say that nth term of Fibonacci is the addition of last and second last Fibonacci term. This kind of formula is always a clue that this method can be written recursively. I won't recommend writing this method using recursion, simply because, If a problem can be written iteratively, then we should avoid recursion, as recursion will be slower than iteration in most cases. Let us try to write this method using recursion. The method shall look something like this. We have a very simple recursive method here that returns the nth Fibonacci term. If the term is either 0 or 1, it returns 1 as per the definition, else it returns the sum of previous two terms. Then we make simple call to method in a for loop. I like the cleanliness of this program, but remember that this method will be slightly slower than the previous method. Then in the recent years, we have seen the emergence of another programming style, namely dynamic programming. The algorithm tries to remember the previous values, so that we can use these previous values to compute new values. In this particular example, we will not see much advantage of this approach, but I decided to add for the sake of completeness. What we are trying to achieve here is that in the method we pass the n, the term that we want, along with a list that has the values of the previous Fibonacci terms. The idea is that if this term is already in the list, we return the term from the list. Otherwise, we compute the nth term from the previously memorized terms, we add this to the list to update the list, and we finally return the nth Fibonacci term. In some implementations, this can really speed up the performance of the method at the cost of some memory. However, in this particular method, the benefits are very superficial. It is here to help you understand different approaches to solve the same problem. In the calling method, we are creating an initial list that has the first two Fibonacci terms. Rest, it is a simple matter of calling the generating method in a for loop. If we perform a benchmarking of these methods, the performance of these three methods is almost identical, and there is nothing to choose among these methods. However, I would like to emphasize here that it is better to stick to iterative approach in most scenarios, as it is usually the fastest. Here as well, it is the fastest approach, although slightly. Let us move on to our actual problem, that is finding the sum of all even Fibonacci terms up to a certain upper limit. Let us define an upper limit up to which we want the sum. We define the upper limit here as 3 million. You may change this as per your specific requirement. So, the simplest and the most straightforward approach to solve this problem is to generate all the Fibonacci terms up to upper limit. While generating each term, keep checking if that particular term is even. If so, keep adding that term to the sum. The method looks something like this. We are familiar with the generation of the Fibonacci approach, the only addition being that now we check if that term is even. If it is so, we keep it adding to the sum. Finally, we display the result. I would like to write this program in C# style as well. It is not a different algorithm, but we are making use of the C# programming constructs. We have an enumerable here. Enumerable is an interface in C# and we can provide an implementation for it. Its implementation results in a collection where each member of the collection is of type int in our case. We can iterate through this collection in C# using for each kind of constructs. The yield keyword provides the next object in this collection. So, we implement the enumerable such that it returns the next Fibonacci term as the next object of collection. The linq syntax allows us to sum the terms that even. linq allows SQL-like queries within C#. The commented code is the traditional way to iterate through an enumerable and sum the even Fibonacci terms. Let us look at the Fibonacci series once again. Pay attention to the terms. Every third Fibonacci term is an even term. Remember, even odd is odd even is odd, and odd is even. This is precise the pattern you observe in this series. With this knowledge available to us, we can write another method that uses this particular pattern. We need to keep on generating the Fibonacci terms, and we need to just add every third term to the sum. This can be achieved by taking a counter term that starts with 3, as our F3 value will be 2 and we want 2 to be added to the sum. Rest of the method is self-explanatory. Whenever the term is divisible by 3, we add the term to the sum. Some of you may be tempted to write this method using recursive Fibonacci generation. Let us write the method and it will look something like this. The recursive Fibonacci method returns the nth term, and then we calling this method in a while loop as long as we don't reach the upper limit. We keep on adding the terms that are even and we finally return the sum that can be displayed. In this example, I have written the method to sum the terms separately and it returns a value to the calling method. All other implementations can be written like this as well. Just wanted to give an example to state this fact. Let us try another approach to write method. It is not a different algorithm but just a different approach. I am showing this approach as this approach will help write an even better algorithm when we write our eighth method. We will use a list in this example. We start by adding the first two terms to this list and the next Fibonacci terms are always the sum of last two list entires. We keep on adding this new term to the end of the list. Once all the Fibonacci terms up to the limit are in the list, we use LINQ to find the sum of the even Fibonacci terms. This method definitely consumes more memory compared to other methods. It is a nice technique nonetheless. There is another mathematical oddity with respect to Fibonacci numbers. The sum of even Fibonacci numbers up to limit is just the half of the sum of all Fibonacci numbers up to limit. This oddity allows to write this method in another simplified way. As you can see, we generate all Fibonacci terms, we keep on adding these and in the end we just display the sum dividing it by 2. There is another mathematical formula related to even Fibonacci numbers. It states that each Fibonacci term is 4 multiplied by the last even Fibonacci term added to the second last even Fibonacci term. With this knowledge, let us write another method. We have a recursive method that returns the nth even Fibonacci term. It returns the first Fibonacci term as number 2 and for every other number it returns the const value as per the earlier mentioned formula. In the calling method, we keep on generating the next even Fibonacci term and we keep on adding it to the sum as long as the term is not up to the limit. This method returns the result that we display on the screen. And finally, we make use of the same formula as in the previous method but we write a non-recursive version. We use a list in this case. We add the first two terms in the list. In the while loop we keep on applying the formula to generate the next term, and we keep on adding the generated term to the end of the list. We are making use of the count property of the list to get the last and the second last even Fibonacci term from the list. All the terms can be added by invoking the sum method on the list. It is one of the prettiest and better performing implementation. This brings us to the topic of performance benchmarking of all these methods. Have a look at this table. The method written using recursive method to generate Fibonacci is the worst performing and it takes ages in comparison to other methods. Rest of the methods are performing at very similar levels. There is nothing to choose much between these methods. I would suggest that you should try all these methods yourself, and choose the one that you like most. Please do let me know in the comments if you come across any other way of writing this method. Do let me know which one you like the most. Thank you all of you for staying this long with me. Happy programming to all of you. Keep programming.